Hello. In this video I'm going to show you how to solve an optimization problem from probably an ordinary Calculus 1 course. And so I'll go through a step-by-step solution, but before I do that I encourage you to try and solve this on your own and then just skip ahead to the end for the solution. So let's get started. We've got two horses that were staying in a rectangular pen that has a perimeter of 150 meters and they start to feud. Pretty clearly shown in the picture here by the aggressive stances and red eyes. So the farmer Susie, decides to fix this problem by using the same 150 meters of fence to make separate pens of equal size. So unfortunately she doesn't have extra fence around. She can't just split the pen in half. She's going to have to use her existing fencing to make two new pens. So what should the dimensions of the new pens be so that the horses have the maximum area to graze? Fortunately to this problem, you don't have to reach the high level of artistic ability I have to create this one here. We're just going to do a simpler sketch. And you can just assume that's a perfect rectangle. I'm going to call one dimension here x and this length y. So at this point, I think it's best to start with the constraining equation. And what's our constraint here? We only have 150 meters of fence. So you want to write that perimeter of all the fencing in terms of x and y. And note here that since it's a rectangular shape, all the vertical ones are x length and the horizontal ones are both y. So if you went out there with a tape measure or something like that, you'd find that the 150 meters of fencing would be equal to 3x plus 2y. Okay, and that would be the constraining equation. Now, what do we want to maximize? The area. So that's a pretty simple equation for this one. The area of this pen for any x and y will just be x times y. And since a is the one we want to maximize, we're going to want to take the derivative of that. But first we need to substitute something in for the y or the x so that we can take the derivative, because right now we have three variables making it kind of a mess. So we're going to substitute in by rearranging this constraining equation. And all you really want to do, I'm going to solve for y and then substitute in for y. So to solve for y, I'd subtract 3x from both sides. So I'd have 150 minus 3x equals 2y. Then divide everything by 2, divide by 2, and you get that 75 minus 3x over 2 equals y. Now what we're going to do is take this value, since this equals y, and substitute it in for this y up here. Sorry, not that y, although it does equal that y, this y. Okay, so what you get is that the area will equal x times 75 minus 3x over 2. And it's nice to just distribute that x for when you take the derivative, so we'll say 75x minus 3x squared over 2. Okay, so now we're ready to take the derivative. But I think it's nice to look at the function you want to maximize before taking the derivative. So let's have a quick peek right here. This is just and this is area on the y-axis. This would show you this equation here, 75 minus 3x squared over 2. So it looks like the maximum is like around 940. And so we can use this to check at the end whether our solution is right. So I'll just write this again. Equals 75x minus 3x squared. Now let's take this derivative. It's not terribly complicated. You get 75 minus, I forgot the over 2 here. So that'll end up just being minus 3x. Okay, and now from here, we're going to set a prime equal to 0 and solve. Okay, why do we set a prime equal to 0? A prime is the slope of the original a. Okay, and this is the a function. At the maximum, you have a slope of 0. So that's the logic behind it. But if you want, you can just ignore that, not even think about it, and say 0 equals 75 minus 3x. And then go ahead and solve this. So I'd add 3x to the other side, plus 3x plus 3x. And now we have 3x equals 75. And you get that x equals 25. So 25 times 3 is 75. Okay, so now we've helped Farmer Susie out. We have one dimension of the pen. Okay, the x length is going to be 25. So let's use that same equation that we had before. We had 150 equals 3x plus 2y. We'll use this to solve. Well, actually, we already solved for y, right? What was it? Y equals 75 minus 3x over 2. So let's just do that. Y equals 75 minus 3x over 2. 3x, you'd put in a 25 for the x, so you get 75 over 2. So 75 minus 75 over 2, that's like something like 37.5. Okay, so at this point you would have the dimensions of the pen. So this y length would be 37.5. If you want the specific one here, you just divide that by 2. Let's just check what that would be. Over 2, you get 18.75. So you're going to have two pens side by side that are 25 by 18.75. Now you might be curious, what is the area of this pen? You would just take those two sides, x, and multiply them. So 25 times 37.5 ends up being, I think, let's see here. 937.5, so that's the value up here. Okay, because for this type of problem, they might ask you for the maximum area or the dimensions of the pen. Make sure you answer for what they're asking for. Alright, so that pretty much wraps it up. If you have any questions, post them in the comments. If you need any help or tutoring with your calculus class, you're welcome to shoot me a message. And if you want to see more videos like this, please subscribe. Thanks for watching.